Hello. Thank you for joining us for Buchi's latest webinar presentation. My name is Jason Wagner, and I'm going to be presenting Buchi's Sepacore Flash chromatography system. I've named this presentation Chromatography Solutions for Difficult Separations. And what I hope to achieve here is to show some of the hurdles and roadblocks that we all face when trying to do preparative chromatography separations. A little bit of background on myself is I've been with Buchi for the past 8 months. For 10 years before that, I was a medicinal chemist in a pharmaceutical company. So I've done multiple separations and dealt with many small organic molecules on a daily basis. So I bring a technical background based in the lab on these separations, and these are some things that I've come across that may help you, and also hope to show you how our system can help you in your separations. This presentation is being recorded, so it can be viewed at any time. You can review it for your information in the future. At the end, I will also present my contact information for any questions, any concerns. Feel free to contact me by phone or by email at any time. So I have a lot of information that I want to go through here, so we'll go ahead and get started. The basic outline, we're going to talk about sample loading techniques. The first thing you have to do is get your sample onto the column, and that can be tricky in different situations, and we'll talk about that. We're going to talk about actually performing your separation on a column and how you're going to choose which column you want to use. We're going to talk about the advantages to our detector and the additional detectors that can be added to our system. And then finally, we're going to talk about fraction collection, the final step of your chromatography separation, and how we can collect fractions in a multiple variety of vessels. So we'll start with sample loading techniques. In a perfect world, you take your sample and dissolve it in a small amount of your initial organic solvents and inject it onto your column via syringe. And we have a simple injection valve that has a one-way ball valve that when you stick a lower lock syringe on, you inject your sample directly onto the column. But what do we do if our sample is not very soluble in the initial solvent system? And this is a problem that I've run into many times. If you're going to run methanol methylene chloride and your sample is not soluble initially in 100% methylene chloride, you might have to add a small amount of methanol, which could affect your separation, but you also can possibly have your compound precipitate and crash out onto the column, either in the syringe or sometimes in the ejection valve. So this is common with polar molecules, especially in more nonpolar solvents, something like hexane or PET ether. You can have your materials precipitate before you're actually able to start your chromatography. It's also very common in my experience with reverse phase systems when you're using water as your initial solvent, and you have organic molecules that maybe aren't very soluble in water. And once they get onto that column, or even in the injection valve, once they see water, they could precipitate out. So in these situations, you can have significant back pressure on the column. And if you have a pump that can push through that and columns that can handle that, you can slowly maybe help dissolve that solid. And that kind of brings us into our first talk about the systems themselves. And the heart of any chromatography system, in my mind, is the pumps. We have 2 pumps that we offer with our systems. They're identical on the outside to view them, but one pump, the C601 at the top, has a max pressure of 10 bar, which is 145 psi. And the second pump is a higher performance pump that's rated for 50 bar, or 725 psi. And at this pressure, you're running into the medium pressure chromatography range, and it opens up a lot of windows with doing reverse phase chemistry, as well as doing large columns and high flow rates. So on the topic of flow rates, both pumps are capable of 2.5 to 250 mils a minute. You'll see that 250 mils a minute is a pretty high flow rate for one pump. If you're running both at the same time, you can have run a very large column. And the other thing to note about our pumps is that they're 3-piston pumps, so there's a pulse-free flow. Basically, what you have is a constant stream of pressure instead of a pulsing effect within the column. So if you can't inject your sample as a liquid, what else can we do? So one thing that's become very popular lately, and I've seen it around a lot, is doing a solid sample injection. And what that involves is taking your sample, your material, and dissolving it in a solvent that it's soluble in, and then concentrating that down onto some sort of solid phase material, usually silica gel, sometimes Sealite. So this is a solution that we've addressed by what they call a prep-elute cartridge. And on the bottom there are two pictures. On the left is a polypropylene prep-elute cartridge. And what you can do is you can fill this cartridge with your material dried onto silica gel, dried onto Sealite. And we offer two sizes, up to 9 grams, and then the other size is a little smaller, up to 4 grams of material. And the way the cartridge works, you can compress your material into a small space so you don't have any dead volume. So you could actually load 50 milligrams of material in there and have no dead volume within the system. So it's a nice way to add your solid sample onto your column. If you need to add a larger amount of material, or you want to run a that with your own material dried onto silica gel or Sealite, and add that in front of the column, and it will slowly dissolve on while your solvent goes through the system. So I wanted to talk a little bit about the solid phase materials that you can use. I picked out 3. Silica gel and Sealite are the top in my mind, but people also use Fluorosil. So the pros on silica gel are that you can sometimes hold baseline materials, the stuff that doesn't move on your TLC plate that's just on the line. And the advantage there is you're not adding that to the top of the column where it's just going to sit for the entire run. You're going to basically pre-capture that on your solid phase and only add the compounds of interest to the column to do the separation. Another pro for silica gel is the dissolution limiting prevents precipitation. So what that means is when the solvent has to dissolve the material off the silica gel in order to add it to the column. So that way it doesn't just wash off the silica gel and then precipitate later on. Some cons with silica gel is that it can retain some compounds permanently that you don't want it to. You also get more separation within that column. If you have a long, thin amount of silica gel with all your material dried on it, some of it's going to come off at the bottom faster than at the top. So you can also adversely affect your separation by using a lot of silica gel for your compound. The other thing is it's slightly acidic. If you have a compound that's not stable in silica gel, obviously this is an issue. And some people are also worried when you concentrate your material on a silica gel, you need to heat it usually, on a rotovap or something like that. So heating and on a slightly acidic material isn't always the best solution. So another option is Fluorosil. One pro with that is that it's neutral. A con is that it can retain certain compounds. This is something that needs to be tested before you run the column to make sure that your material will not be retained on the Fluorosil. In my experience, I've used Sealite an awful lot. The pros with that is neutral. It doesn't retain compounds. And the nice thing about it not retaining is as soon as the solvent front hits that Sealite with your material adsorbed onto it, it all pushes off and flows onto the top of the column more in a narrow band, in my opinion, than it does coming off silica gel. So one of the cons there is you need to add a little bit more Sealite than you would with silica gel just because it doesn't have as much surface area or capacity to hold the solid sample. And since it does flush off the Sealite so quickly, you can have sample precipitate on the column head if you have a very insoluble compound. So it's something to try. Those people out there who are using silica gel might want to try Sealite and see how it works with their compounds. The non-retention factor is a big benefit in my opinion. So another thing I wanted to talk about with the solid sample injection was doing this in a parallel synthesis type of fashion. So on the bottom right, we have a Syncore polyvap, it's called. The Syncore is a parallel evaporation system that we also sell, and I'll also talk about it later with our fraction collector. But what you can do with this Syncore, it holds multiple tubes of your sample. You can put your sample in with the solid phase of your choice, and you could dry multiple samples all at one time. And we can also use a rotovap condenser. There's a condenser shown hooked up to the Syncore, but you can also use a condenser that's built into your rotovap. But you can dry multiple samples at one time and then sequentially take those and chromatograph them. So I just wanted to discuss that, there's other ways to do this in a parallel synthesis fashion. And the other advantage here is that you get high solvent recovery. You're not just using nitrogen to dry your sample and blowing organic solvents off into the hood or into your vacuum lines in your lab. The next way to get a sample on after just using a small syringe or doing a solid load is to do a large liquid injection. And you'll see that there are 4 different vessels that we have here available that go from 100 milliliters to actually a full liter. And the benefit here is you can load dilute samples onto a column. That's something that needs to be dissolved in a large volume of solvent. But also, if you're running a very large column, we have pre-packed columns that go up to 1,600 grams of pre-packed silica gel. So that's up to 160 grams of material that you could load onto the column. You obviously are going to need quite a few milliliters of solvent to dissolve that and add it to that. What this system does is it allows you to add that large volume in a closed system. There's a dry gas pressure feed on top of this column, and when you use it in conjunction with a valve system, you can add your solvent directly onto the top of the column without having an open system, without having to use very large syringes, and you use that pressurized dry gas to push it onto the column. These columns are made of glass. They're plastic coated because they're under pressure to add in the safety of those columns. So now that we know a bunch of different ways to get the material onto the columns, how do we choose which column we want to use? Well, there's different columns, and then there's also different phases within the columns. We offer 3 different types of columns. We have pre-packed columns that are shown vertically in the stand arrangement there that a lot of flash chromatography systems have. But we also have glass columns that you can pack with your own material, and then we have polypropylene cartridges that you can pack using an instrument that that Buchi sells and has invented. So I'll go through these 3 different column choices. The pre-packed cartridges are a lower lock connection. They can fit into our instrument and any other flash chromatography instrument as well. They are packed with 40 to 63 micron silica gel, so it's a narrow range of silica gel that aids in the flow through the system and also the separation ability of it. These columns are in normal phase silica gel are nice. You can pull it out. It's pre-packed. You use it. You flush the solvent off, and then you discard it. So it's a very quick process. There are also some columns that can be reused, like reverse phase and amine columns, that can be used and then stored in solvent and then reused again. So it's a nice, quick solution for chromatography. We offer multiple packing phases that I'll talk about a little bit further on, but we offer these in 4 grams up to 330 grams for most, and then in silica and reverse phase, we offer 800 and 1600 gram columns. So we're talking pretty large columns, and at a 10% load volume, you're up to 160 grams of material that you could add to a silica or reverse phase C18 column. The first type of specialty silica that we have is called our HP packing, and it stands for high performance packing. On the graphical representation below, you'll see a normal silica gel column, 4 grams, with 3 different peaks in there. That is a theoretical plate calculation of 82. The high performance 4 gram column is 185, so more than double the theoretical plates, which equals more separation efficiency. And that separation that you see on the second graph, the baseline separation that you have there, you could actually load more material because of that increase in separation. So if you have a difficult separation, you can use high performance packing, but also by using the high performance packing, you can add more material to the column than you typically would be able to with a larger particle sized column. So this is a graphical representation of how to get started choosing some of the different phases that are available for flash chromatography. In a perfect world, we'd all have low and medium polarity compounds that would just separate just fine in silica gel in your normal solvent systems, but that's not always the case. So I have little pictures below of our diol cyanoamine, our reverse phase C18, and then strong cation exchange, which is SCX, a toxic acid derivative. And here is how you would pick, say, a charged molecule. You would typically do a reverse phase, or you could use a strong cation exchange and do what's called a catch and release type of column. For acidic and basic molecules, regular silica gel, but then also using the cyano columns is a good choice. For a high polarity, usually reverse phase is a good choice, but if you don't have access to that type of system, a cyano or even amine columns also work well. One thing that you'll notice, and it's the same slide, but I've highlighted, cyano silica gel, cyano cap silica gel is found in all of these categories. And the reason being is because it can be used as normal phase or reverse phase silica, depending on the solvent system that you choose. If you use an aqueous system with a methanol or acetonitrile type of solvent system, it can be used as reverse phase, but then you can use it for hexanethyl acetate, normal phase chromatography. So that's one. If you were going to have a few extra types of silica gel laying around, that would be one that maybe you'd want to stock because it can be used for various things. Now, I do know that most people have a large stock of normal phase silica gel, either in bulk form or in pre-pack columns, and sometimes that's what you have to deal with. So these are just some things that I've kind of come across in my experience. And you have compounds that are not stable in silica gel sometimes. I've taken HPLCs and you see one peak and you put it on a TLC, and for some reason there's two peaks there or there's three peaks there. And it turns out your compound can decompose or do other funny things on normal phase silica gel just because of that slight acidity. What you can do is you can deactivate the silica gel by you condition the column in 1 to 3% triethylamine solution, and then from there you can run your sample safely, and you don't actually need to use any more of that triethylamine solution in your solvent system. If you don't want to, you could continue using it if you felt that was necessary. For very polar compounds, typically I would run from 0 to 20% methanol in methanol methylene chloride. I put an asterisk there because a lot of people are wary of going over 10% methanol in their solutions because the silica gel begins to dissolve at a certain undetermined point because it depends on what the quality of the silica gel that you have. If for any case, if you use 20 or 30% methanol and there's a small amount of silica gel, what you can do is take your sample, redissolve it in methylene chloride or something like that, and then filter off the silica gel after you've concentrated your fractions. But another way around using such a high amount of methanol is to add ammonia or ammonium hydroxide to your methanol solution, usually in a 10%. So that way when you're using 10% methanol, you only have 1% of the base in there. And usually what happens is your molecules will have a higher RF, they'll move faster through the column, but also it can help sharpen up peaks, especially tailing peaks that tend to drag off for a long period of time. And then for charged molecules I have below, if it's charged while it's on the column, it's going to have a lot more interactions on the column and have a lot of tailing. So an acidic compound, you can add some TFA or formic or acetic acid. And basic, we have triethylamine and ammonia there to help modify the solvent system and keep those peaks nice and sharp. Okay, so that's what I have for the pre-pack columns. Now we're going to talk about the polypropylene cartridges that you can pack yourself using our instrument. It's called the C670 cartridger, and it's pictured on the right. I have a neat video of it working, but it doesn't work on this webcast. So on the next page, I have a little stepwise pictorial on how to pack your own column. But I did want to mention that the C670 is now included free with any of our full systems. It's the X10 and X50. That's a complete system with pumps, detector, fraction collector, and computer software and all that kind of stuff. So it's about a $5,000 value, and we're offering that free with our full systems at the moment. So I'll show you real quick how this works. On the top row is the cartridger empty. In that glass vessel, in the bottom is where you're going to put your silica gel, but the bottom is actually a frit. So you're going to have dry gas that you hook up to the instrument. Dry gas will bubble through the silica gel and fluidize it. And what that does is it makes it more homogeneous, so you get an even packing when you pull the silica gel up into the column. Then the other component of the system is the tube at the top, and there's like a wand up there. That wand is actually hooked up to a vacuum source, a vacuum that you would use for, say, a rotovap. In the second row, they show filling the silica gel, putting that black lid on there, and it's kind of hard to see in the picture, but that black lid has some tools in it that help you pack the frits into the polypropylene cartridges. So the third picture on the bottom, they show a polypropylene cartridge putting a small frit in the bottom. Then they hook it up to the vacuum source and stick it in the silica gel. They show on the top of this page turning the vacuum on. In the second picture, you pull silica gel up into the cartridge while it's under vacuum. You keep it under vacuum, and you pull the cartridge out. You flatten the surface of the silica gel, and that's what the turning arrows is indicating. And you put another frit on the top of the lid and seal off your cartridge. Turn off the vacuum and unscrew your cartridge, and you're good to go. If anybody would like to send me an email later, I can send a video file of this. It's around 10 megs, so it's a little bit large, but it's actually neat to see in person. So with that cartridger, what you can do is you can buy bulk silica gel, reverse phase, whatever you choose. And in the U.S. it costs 2 to 3 cents a gram to buy bulk silica gel, and you can pack your own columns. And those polypropylene cartridges can be reused again. You just have to replace the frits. So the third choice that we have, other than the pre-packed columns and packing your own, are glass columns, which also you pack by your own, but they are made for higher pressure uses, also for very large scales. So we have a column that is almost a meter long and 100 millimeters wide if you choose, but we also have small columns that will only hold 4 to 10 grams of material. So with these columns, we can separate almost 400 grams of material on the large end. They hold a lot higher pressure than any pre-packed polypropylene cartridges. Pressures up to 50 bar that our system is capable of. And you also have clear glass that you can see your compounds as they move through the column. So once again, you can pack these on your own with any silica gel that you choose. It's also a really good choice if you have a reverse phase column that has more expensive reverse phase silica gel, and it's going to be reused again. You can pack one of these columns and then use it multiple times. So the next thing I wanted to talk about was our detector capabilities. And the detector that comes with our full system is actually a UV-Vis diode array detector. The diode array is usually seen in HPLCs, not so much in the Flash systems. But what it offers us is 4 wavelengths of detection. You can monitor 4 wavelengths at one time. You can collect based on those 4 wavelengths. You can also collect based on 1 wavelength and just monitor the other 3. It gives you lots of options. If you just want to see 254, that's fine. You can base your fraction collection on that, but you could also put in some other wavelengths and, just be certain that there's nothing else in there that maybe you would want. The range is 200 to 840 nanometers. Now, on the diode array part, on the bottom picture, you can see we can do on-the-fly scans of the full UV Vis spectrum from 200 to 840 at any point during the run. So if you see a color coming off the column, and whatever's in the flow cell is what's going to show up, what it's going to do a full scan on. So if you see a color come off, but it's not really showing at 254 that you chose, you can do a full spectrum scan and see what the max absorption of that is. At the top of any large peak, you could do a full spectrum scan and see if maybe you have co-eluting fractions, or maybe just a better UV-Vis signal for your next time that you run. Maybe it's actually better looking at 260 versus 240 or something like that. So it offers a lot of flexibility in just one detector. Once again, 4 wavelengths at a time. Now, this isn't a very exciting piece of equipment, but what this controller does is talks to the computer and talks to all the parts that are included, so the pumps, the fraction collector, the detector. And what I have circled in red is another 4 ports that can be used for additional detectors. At the end of the year or the beginning of this year coming up, 2013, we're hoping to release an ELSD, evaporative light scattering detector, that can detect any compounds that are passing through, no matter if they have a chromophore or not. But you can also hook up a refractive index, fluorescence, conductivity, various other types of detectors can be hooked up and used simultaneously with the C640 UV vis detector. So you can actually have 8 different signals that you're determining your fraction collection on, or that you're just monitoring. So it offers a lot of flexibility for even for compounds that don't have a good chromatophore in your separation. So here's just a little bit about the ELSD. It's a standalone piece of equipment that comes beside the instrumentation, and the graph I have on the right shows a UV chart in black with just one peak here for the chromatophore. But there's also a steroid type of derivative in there, and you see a strong peak in the gray from the ELSD that you would not have detected without this ELSD detector. So it offers more flexibility with being able to see other molecules that are in your sample that may not have a chromatophore. So the last thing I want to talk about quick is fraction collection. And it doesn't sound very exciting, but what we have for our fraction collector is a very large bed that you can fit up to 4 of our fraction collection racks on. That will collect up to 12 liters of solvent or up to 240 fractions in smaller test tubes. So we offer 3 different size test tubes, standard with the system that you can choose from. But on this rack, you can also fit any vessel of your choice. So that's what I want to show you in the next slide. We have a rack wizard where you can build your own racks, save them, and then use them in the future. The rack shown here is a pre-programmed rack that was shown in the picture before. It's got 25 millimeter test tubes, and you can see you fit 30 in each rack, and you can fit 4 racks on there. But say you wanted to collect large volumes of solvent. This rack that I created has 12 250 or maybe 300 mil Erlenmeyers. And there's a picture on the left there that shows you a picture of what glassware you've chosen, and I added that in. So anything that you want to collect in, you can add that, so that way when you're using the system, people will know, okay, well, this is set up for an Erlenmeyer. But what you can do here is collect large volumes of sample in any type of vessel that you want. So just for fun, I made this rack with 100 shot glasses. Just to show that even a small, if say it was a scintillation vial instead of a shot glass, you could collect in small vessels. You could also put 2-liter bottles on there and have it collect in them as well. The last slide that I want to talk about with the fraction collector has to do with our parallel evaporation system. And it's a small graphical picture on the left there that shows the rack itself, but you can see it's 12 position collection. And what you can do is use this aluminum block rack on the fraction collector, collect your samples directly into it from your chromatography, and then take that rack and put it right onto the Syncor parallel evaporation system without any solvent transfer. You don't have to dump tubes in anything. You can just move that right onto the parallel evaporator and concentrate it down to dryness, or you can actually do it to a residual volume if you so choose. The other advantage here, once again, with this parallel evaporation is you have very high solvent recovery. I think it's around 98%, but you're not blowing that into the hood. You're also not having to transfer over to a rotovap and having to concentrate down multiple samples at different times. You can do it all at once. So I know I rushed through a lot there. We're running close to our half-hour time limit. That's the conclusion that I have. Once again, I know I talked about a lot of information, and if anybody wants to contact me, my email address is my last name, Wagner, W-A-G-N-E-R, .J for Jason, @Buchi.com. And my direct phone number is 302-225-2442. And I wanted to see if anybody had any questions here. Okay, we have one question. Can the fraction collector be used by itself? Yes, the fraction collector, any of these, instruments can be used, well, a lot of them can be used as a standalone instrument. The fraction collector can be set, it has its own screen on it. It can be set to collect via time so or volume. So you could tell it to collect 30 mils in each tube, and you could actually hook that up to a gravity column in your hood. You know, an old glass column and you're using air pressure to push through. You can have the fraction collector switch tubes at certain times and use that just by itself. The pumps can be used. They need to have a small controller used with them, but they can be used on their own without the full computer system. So there are multiple variations of how you can configure the parts of the Sepacore. Okay. And the other one was, do you need to use a computer? Like I said, you do not need to use a computer. Everything can function on its own. There are other small controllers that you would add that isn't necessarily a computer, but a small screen with different choices on pump flows or to set up the fraction collector. But a computer is not needed to run these instruments in a lab. And I think that's about it for time. Once again, I welcome any questions or any concerns or whatever about my presentation, and I'm glad that everybody was able to attend, and look for more Sepacore presentations in the future. Thank you.